Before you finish reading the sentence, look down at your right hand. Not later, now. Turn the palm toward your face and find 2 fingers, the one you point with, and the one beside your smallest finger. For the vast majority of people on this planet, one of those 2 fingers is noticeably longer than the other. It's such a small detail that almost nobody stops to examine it. But a smaller number of people look down and find something unexpected. 2 fingertips ending at almost exactly the same line, as though nature drew a ruler across their hand and stopped both fingers at once. If that's what you see, you're not imagining a coincidence. You're looking at the surface of a biological event that happened before you had a name, before your parents had even met you, back when you were smaller than a grain of rice, and that event was never supposed to be visible to anyone. Yet somehow it's been sitting in plain sight For decades, this measurement puzzled the people who study it. Anatomists noticed it. Anthropologists working in a remote village, asking a different question. Instead of asking what the fingers looked like, they asked what built them. And that shift in thinking cracked open one of the strangest paper trails hidden inside the human body. Scientists call it the digit ratio. More precisely, the 2nd to 4th digit ratio, or 2D, 4D. It's a simple idea on paper. You measure the index finger from the crease at its base to its tip, then measure the ring finger the same way, then divide one length by the other. That single number, often somewhere close to 1.0, has quietly become one of the most cited measurements in modern developmental biology. Not because the math is complicated, but because of what it turned out to be hiding underneath. The story of how anyone noticed begins with a British biologist named John Manning, who in the late 1990s started measuring hands obsessively. School children, professional athletes, musicians, patients, and fertility clinics. The pattern he found didn't behave like ordinary variation. It behaved like a signum L. And the group that intrigued researchers most wasn't the people with a short index finger or a short ring finger. It was the people whose fingers matched almost perfectly, sitting right at that rare middle point where the ratio hovers near 1. Here's what makes this measurement genuinely strange, and why it earned so much scientific attention. Unlike almost every other feature of your body, it doesn't change. Your weight changes, your muscle tone changes, your face ages, but the relative length of these 2 fingers is fixed for life by the time you're born, and it never moves again. Not with exercise, not with hormones you take later in life, not with age. Whatever ratio you had at 5 years old is the same ratio you'll carry at 85. That kind of permanence is rare in biology, and it made researchers suspicious in the best possible way. A trait that can't be altered after the fact is a trait you can trust as a kind of... The window in question is astonishingly narrow. Somewhere around the 8th week of pregnancy, while the embryo is still barely the length of a fingernail, the hand is being sculpted out of a flat plate of tissue. The fingers are separating, lengthening, taking their final proportions. And during that exact stretch of days, the developing body is awash in 2 hormones that will go on to shape almost everything else about human biology: testosterone and estrogen. Researchers eventually discovered that these 2 hormones don't affect the fingers equally. Testosterone preferentially lengthens the ring finger. Estrogen favors the index finger, so the ratio between the 2 hormones circulating during that narrow prenatal window quietly decides a proportion that will stay fixed for the rest of that person's life. Lean toward more testosterone in that window, and the ring finger outgrows the index, producing a lower ratio. Lean toward estrogen, or toward a more balanced hormonal signal, and the 2 fingers finish closer to even, producing that rarer. Matched patterns so many people never notice on their own hands. For years, this remained an educated guess, a strong correlation without solid proof of mechanism. Then, researchers turned to developing mice, examining the actual cellular receptors, the microscopic docking sites where testosterone and estrogen physical bind to tissue as the paw forms. When they experimentally increased testosterone signaling, the 4th digit stretched out disproportionately. When they blocked that signaling, the digits evened out. This wasn't correlation anymore. This was cause and effect observed directly inside a growing limb. And there was a reason the 4th digit responded so strongly. It carries a noticeably higher concentration of androgen receptors than the index finger does. It is, quite literally, built to be more sensitive to testosterone. When hormone levels run high during that developmental window, the ring finger has more molecular catchers waiting to receive the signal, and it grows accordingly. When hormone levels run lower, or when estrogen holds a stronger share of the balance, the sensitivity gap narrows and the fingers finish nearly equal. The clinching evidence came from an entirely different kind of study, one that didn't need mice at all. Researchers found a way to sample the hormone levels a developing fetus was actually exposed to, using amniotic fluid collected during pregnancy. Years later, they returned to measure the finger ratios of those same children, now grown. The correlation held almost perfectly. Higher measured testosterone exposure in the womb predicted a lower ratio in childhood. Lower exposure predicted a ratio closer to even. A prenatal hormone level, recorded before a child could open its eyes, had accurately forecast the geometry of a hand that wouldn't be fully examined for years. This is what makes the digit ratio such a peculiar tool for scientists. Almost every other window into prenatal development slams shut the instant a baby is born. You cannot retroactively measure hormone exposure from 30 years ago, but the hand keeps a receipt. It holds a physical record of an internal chemical event, preserved in bone and tissue, readable by anyone with a tape measure and a little patience. It is, in a very real sense, one of the only visible fossils of your own fetal development still walking around on your body. But identifying hormones as the mechanism only pushed the real mystery backward by one step. Because the next obvious question is, what decided how much testosterone or estrogen a particular fetus was exposed to in the first place? What decided how many receptors a particular ring finger would carry? Two fetuses can develop in two different wombs and emerge with dramatically different hormonal signatures. So something upstream has to be steering that variation. And it isn't the hormones themselves. It's the genetic code instructing the hormones how to behave. Twin studies were the first strong clue. When researchers compared identical twins, who share effectively all of their DNA, their digit, ratios matched each other far more closely than the ratios of fraternal twins, who share only about half their genetic material on average. That gap is the unmistakable signature of a heritable trait, something coded, inherited, and passed down through family lines, rather than something shaped purely by the environment of a particular pregnancy. Continent, some eventually crossing into the islands of the Pacific and the vast landmass of the Americas. Each time a group broke away and settled somewhere new, it carried with it only a fraction of the total genetic diversity present in the parent population, a phenomenon geneticists call a founder effect. Over the many centuries of relative isolation that followed, certain gene variants became common in one region purely by chance, while other variants became common somewhere entirely different. The finger-building genes rode along on those same ancient migration currents. And when researchers began compiling digit ratio measurements from populations around the globe, sampling groups in Europe, across sub-Saharan Africa, throughout the Middle East, South Asia, and East Asia, a genuine regional pattern began to surface from the data. It wasn't a single study or a single lab making a claim. It was decades of independent research, conducted by different teams using different methodologies in different countries, converging on the same broad observation. Average digit ratios differ measurably from one ancestral population to another. In some regions, the data leaned heavily toward lower ratios, ring fingers reaching visibly past the index. In others, particularly across East Asian populations sampled in China, Korea, and Japan, the average ratio tended to sit noticeably closer to that balanced point near 1.0, the pattern where the two fingers finished nearly level. That doesn't mean every individual within a region shares the same hand shape, population. Averages describe a center of gravity for enormous groups of people, not a rule for any single person sitting in front of a mirror. Within any population on Earth, researchers find the full spectrum of ratios, low, high, and everything between. What shifts from region to region is simply where that overall distribution tends to center. Still, the regional signal has proven remarkably durable. Across measurements of tens of thousands of individuals, hunter-gatherer communities, dense urban populations, men, women, children, elite athletes, the broader pattern has held up again and again under independent scrutiny. That kind of reproducibility is rare in behavioral or morphological genetics, and it's exactly what convinced researchers that the digit ratio carries a genuine, if statistical, ancestral fingerprint, a faint echo of population history compressed into the shape of a hand. It's worth pausing here, because this is precisely the point where popular science communication tends to go wrong, and where genuine caution matters. A population average is not a diagnostic tool for any individual. Plenty of people with deep European or African ancestry have close to equal fingers. Plenty of people with deep St. Asian ancestry have a pronounced low ratio. Your hand cannot function as a home DNA test, and anyone claiming it can read your precise heritage from a single measurement is overstating what the science actually supports. What the research genuinely shows is a probabilistic tilt, a shift in likelihood across large populations, not a verdict about any one person's ancestry. But the fact that it's only a statistical tilt doesn't make it meaningless. It's still a real, measurable, heritable signal, tracing back through prenatal hormone exposure, through ancient HOX gene variants, through founder populations that split apart tens of thousands of years before written history began. In that sense, an equal digit ratio isn't a coincidence of anatomy. It's a faint echo of a hormonal event that occurred inside a womb shaped B by genetic instructions inherited from a chain of ancestors stretching back further than any family tree could ever record by hand. The research didn't stop at ancestry either, because the same prenatal hormone balance investigating whether digit ratio correlated with anything beyond hand geometry. Some studies have reported associations between lower ratios, the pattern linked to higher prenatal testosterone, and certain strengths in spatial reasoning, along with a higher prevalence among some groups of elite athletes. Other research has reported associations between higher, more balanced ratios and certain verbal processing tendencies. A smaller body of work has even explored possible links to specific long-term health patterns, on the theory that the same hormonal environment shaping the hand might leave subtler traces elsewhere in the body. These findings deserve real skepticism, though, and the honest scientific literature treats them that way. These are faint statistical patterns that only emerge when averaging across thousands of people. They carry essentially no predictive power for any single individual. A finger ratio cannot tell you what you're good at, what career suits you, or who you're going to become. What it reliably points back to, again and again, is that one narrow prenatal window, a signature of a moment in early development, not a prophecy about a life. It's worth being precise about what equal actually means, because there's a meaningful difference between the three broad patterns researchers describe. When the ring finger clearly extends past the index, that person sits in the lower ratio group, shaped by a comparatively stronger testosterone signal during that 8th-week window. When the index finger extends past the ring, that person sits at the higher end, shaped by a comparatively weaker testosterone signal relative to estrogen. But the balanced hand, where both fingertips land almost exactly together, represents neither extreme. It's the hand of a womb, where neither hormone decisively won out. A fine equilibrium struck during a 2-week span before either parent could have possibly known it was happening. If you want to check your own ratio with any real accuracy, researchers recommend looking at the palm side of the right hand specifically. Evidence suggests the effect tends to show up more consistently on the right hand than the left, for reasons still not fully understood. Locate the crease at the base of the index finger and the crease at the base of the ring finger, then measure straight to each fingertip from those creases rather than eyeballing it from the back of the hand, where knuckle position distorts the comparison. If the two measurements land within a hair of each other, you belong to that balanced group. Statistically more common across certain ancestral lines, but never on its own proof of exactly where you come from. What makes this whole area of research so quietly remarkable is how ordinary the evidence looks. No lab coats, no sequencing machines, no waiting weeks for results in the mail. Just two fingers you've glanced at thousands of times without ever really seeing them, carrying the whole while a compressed record of a hormonal balance. Struck inside a womb you have no memory of, built from genetic instructions passed down a line of ancestors you will never be able to fully trace, shaped by migrations that scattered across the earth tens of thousands of years before the first city was ever built. We spend extraordinary amounts of money and effort trying to learn where we come from, mailing off saliva samples, waiting on ancestry reports, searching archives for names and old parish records, and the entire time, a quieter, older version of that same story has been sitting at the end of our own arm, written not in ink, but in bone and cartilage, needing nothing more than a moment of attention to be read, the body. And it turns out, has been keeping records no one ever asked it to keep. Patient, silent, and exact, waiting for someone curious enough to finally measure it,